Okay, so what we're going to look at now is another application of number theory and a standard question that you might get in the exam. So are there any integers n for which this fraction here is also an integer? So we don't just want the fraction to be reducible, okay? We want actually the end result to come out as an integer. So in other words, we need n plus 3 to be a factor of 2n subtract 5. Now, a lot of students don't know how to get started with this type of question. Okay, and something to look out for, and this will benefit you in other topics in single maths like integration, domain and range, sketching reciprocal functions. But if you have a fraction like this, where the highest power in the numerator is the same as or greater than the highest power in the denominator, then you should start by doing algebraic division, because essentially what you've got yourself is an improper fraction and you want to write it in terms of a quotient and a remainder. So if we look at this fraction, the highest power in the numerator is 1, because we got 2n, which is the power of 1. Okay, in the denominator, we got n, which is just to the power of 1 as well. Some other scenarios where you might want to do this is if you had a quadratic divided by a linear equation, or a quadratic divided by a quadratic, or a cubic divided by a quadratic or a linear. Okay, but algebraic division is a good start point for lots of different questions, including this one. So I'm going to set up my division, 2n subtract 5, and then n plus 3. Then we're going to start by doing 2n divided by n, which would give me 2, which I'm going to write in my constant column. And then we're going to take that 2 and times by n to get 2n, which I'd write in my n column, and then do 2 times the 3, which gives me 6, which I'm going to write in my constant column. Then we're going to subtract to find a remainder. 2n subtract 2n is 0n. Negative 5 subtract 6 is negative 11. Now the power of negative 11 is less than the power of n, okay, because n is to the power of 1, whereas in negative 11, the power of n is 0. So therefore, we can stop there. We've essentially found our remainder. Okay, so what we can do is rewrite our initial fraction and write that it's equal to our quotient, which is 2, so that came from up here, and then plus our remainder, which is negative 11. But remember, our remainder has not been divided by our divisor, which is n plus 3, so I'm going to write that in the denominator there. And actually, really the best way to write it is, because that 11 is negative, I'm actually going to bring it to the front of the fraction like that, okay, because it's a bit neater. Now that I've rewritten this, we know that the right-hand side is equivalent to the left-hand side. So if I want to make the left-hand side an integer, well, I need to make the right-hand side an integer. So I need to just focus on the right-hand side now. Now the right-hand side has an integer, subtract another number. Now, if you have an integer, subtract another number, and you want the result to be an integer, well, that second number also needs to be an integer as well. Okay, so what we require is we need 11 over n plus 3 to be an integer. If that's the case, then the original calculation we were looking at will also be an integer. So in order to figure out what n could be to make that happen, is that we just need to think, well, what other factors are of 11? What numbers can we do 11 divided by something, and that results in an integer? Okay, because that's essentially what we need the n plus 3 to be. We need this to be a factor of 11. So that means n plus 3 could be equal to positive 11, okay, because 11 is a factor of 11. N plus 3 could be equal to 1, because 1 is a factor of 11. But don't forget about negative factors in this scenario, because they haven't said positive integers n. So therefore, n plus 3 could also be equal to negative 11, or n plus 3 could be equal to negative 1. Now we have 4 simple linear equations that we can solve. So we get n is equal to 8, n is equal to negative 2, n is equal to negative 14, and n is equal to negative 4. So therefore, these are the values n that are going to make that calculation an integer.